Hello and welcome to the lab on tcpdump. So tcpdump is a very popular packet sniffer and it's widely used to sniff traffic on different network interfaces. However, not only can it capture live traffic on interfaces, you can also give it an offline trace of packets that you have already captured, and tcpdump can still go ahead and analyze that as well. So in this lab, we are going to demonstrate how tcpdump, a very popular packet sniffer, can monitor different types of traffic on network interfaces. So as usual, before you start, you need to do this prerequisite. Let's go to the labs folder, open terminal here, and let's run main script. Kelly. And this time we want to start the tcpdump lab, which is number 4. And it looks like everything is ready. So basically we can start listening to the traffic. So just a quick word, as before, this is our Kali Linux virtual machine. Here we have the Kali Linux terminal where we're going to run the different commands. And in this lab, basically we're interested in using tcpdump to monitor this Docker 0 interface. So it's going to sniff on this one. And the IP address of Kali Linux is basically 172.17.0.1. So tcpdump is going to monitor all the traffic that is going in this direction as well as in this direction, depending on which filter you have used. So let's go ahead and do that. So the first command to listen to the traffic is sudo tcpdump -i docker 0 and -v. Let me clear the screen and let me zoom in. So the command is sudo tcpdump. So we are using sudo because we need elevated privileges since you're running a packet sniffer on a network interface. So definitely you need to do that. Now -i docker 0 basically means that listen on interface docker 0. And docker 0 is the interface between Kali Linux VM and the Nginx container. Okay, and then we want to use -v flag. So once again, we need sudo because we need elevated privileges. tcpdump is the name of the tool itself. -i always specifies the interface on which you want to listen. So in this case, we want to listen on docker 0, but you could also listen on, for example, Ethernet 0 or other interfaces. It can even be wireless interfaces. And then -v basically says that give us a bit more verbose response. We need a bit more details about the packet headers, packet content, and those kind of things. Just gives you a bit more details. So let's do that. Okay, so tcpdump is now listening on docker 0 interface. Since you can't use this window anymore, so let's open a new tab. So here what we want to do is, first of all, we want to send some traffic over the interface so that then we can see whether tcpdump has sniffed it or not. So the first one is simply to ping from Kali Linux to the Nginx container. So let's do that. Let's stop it. There you go. So as you can see, it has sniffed the packet correctly. So ICMP echo request and then ICMP echo reply and a bunch of these. So far, so good. So tcpdump was able to listen to this ping traffic, which uses the ICMP protocol, and it was able to see both the requests and the reply messages. Okay, so the request as well as the reply messages. So far, so good. Now let's also do the nmap port scan to see if it can also detect that one. So nmap port scan of port 22.17.0.2. This is the Nginx container IP. Now let's go here. Okay, and as you can see here, this shows TCP traffic and it's going from Kali Linux VM to the Nginx container, which is the IP address that we used, and it's going to port SSH, which is port 22. So far, so good. Let's move on. So usually it's very rare to basically run the TCP dump in the all listening mode, because here we haven't specified any filter. We are saying just monitor all the traffic on this interface. Now, since this is a controlled lab environment, so you're not seeing a lot of traffic. But in real networks, you're going to see thousands upon thousands of logged messages, and it will be very hard to decipher what's going on. And that's really a rookie mistake usually. You never want to listen to all kinds of traffic, unless of course you're capturing that for an offline processing. So typically what we do is that we use something which we call filters. So for example, in this one, you can filter. You can say that I just want to listen to all the traffic going to destination port 80, for example. Okay, so I'm going to do Control plus C to stop this one, and I'm going to run the command again, but this time slightly different. So we want to add destination port 80. This means that run tcpdump again on interface docker 0 in verbose mode, but just give me the traffic which has destination port as 80, which means that, for example, if you're sending traffic from Kali Linux to the Nginx container, I only need the traffic which is going to port 80 or HTTP on Nginx container. Okay, so let's see that. Now going to the other tab, let's first check whether it's going to still detect traffic going to port 22 or not. Okay, so we should not see any capture. So let's run the command again. And there you go, there's nothing. Okay, so the filter is actually working. So it's only going to filter and show us the traffic which is going to destination port 80. Okay, so what's the next one? Let's try on port 80. Let's do an nmap scan on port 80 and see if it can detect that. Okay, let's come here. There you go. It has already detected the traffic going to port 80. So for example, if you look at here, this is from Kali Linux VM and this is going to port 80, which is HTTP. Excellent. Moreover, you can also open the browser, for example, and go to port 80. So whenever you open this Nginx web container in a browser, it's going to default to port 80 and it's going to display a message. So let's do that. So let's go to HTTP and then 172.17.0.2. So this is the Nginx web container and you're seeing the web server running there. Now let's go back. I'm just going to close it because it's going to generate a lot of traffic. So let's go here and see. So we had the get command, get HTTP request executed. Okay, and you can see it from here as well. And then there's lots of other information as well. So opening that browser created a TCP session from Kali Linux VM to the Nginx web container on port HTTP, and this was the get operation. We have already filtered on destination port. Now we want to filter on the host. So basically, what does it mean? You can also filter, like for example, I want only traffic going to or coming from this IP address. So let's do that. So let me clear the screen. Now, instead of this one, destination port 80, what we want to do is that we want to specify that any traffic going to or coming from this host, we want to see that. So you can say host 172.17.0.2. And this is going to basically again show all the traffic going to either to the Nginx container or originating from the Nginx container. So let's just do a small ping and then we can be sure. Let me stop it. There you go. Once again, it has been able to pick the ICMP echo requests and reply messages. Perfect. Moving on. Now you can also filter on protocol and the source. So what this means is that you can say that, for example, I just want to see ICMP protocol, which is basically the ping one. And then I just want to make sure that any traffic which has the source host as this one. So if you just specify host, then it means that you just want this IP, either the source as the destination. But if you say source, then it means this has to be source. Okay, let me stop this one, clear the screen. So now we are saying that we want just ICMP traffic and with the source host originating from basically .17.0.2. Okay. Now, can you think of what type of traffic are we going to see? So ping traffic and with the source Nginx container. Okay, if you guessed it, great. If not, basically we should be only seeing the ping reply traffic. Okay, we are not going to see the traffic which is going from Kali Linux VM to Nginx container because it will not match this filter. This means it's coming from Nginx container, which would be the echo replies. Okay, so let's try that. So just to be clear, we again use the same command. So basically we're pinging the Nginx container from Kali Linux, but we are going to receive the replies. Okay, so let's go here. There you go. We are not seeing any echo requests, but we did see echo replies. Perfect. Moving on. Okay, moving on. So now an interesting capability of tcpdump is that it can read and process packet capture files. So in real life, so usually what happens is that tcpdump is listening to different interfaces and using different types of filters, but it's usually writing to a packet capture file. And then if something happens, that packet capture file can later on be analyzed and parsed using tcpdump or Wireshark or other tools to investigate what really happened. And in this part of the lab, we're going to simulate exactly that. So we have a file which is located at tcpdump. So this is the folder name, and capture.pcap is the file name. This capture file includes packet captures that we have recorded between Kali Linux and Nginx container, as well as some other traffic. So for these, you need to try out these filtering commands. But now, instead of using the Docker 0 interface, you're just going to pass this packet capture file to tcpdump, and it's going to parse through it, apply all the filters, and give you the results. Okay, so let's start with the first one. So we are going to repeat the same command for filtering on protocol and source, but this time we're going to use the pcap file. So sudo tcpdump as always, but now we're going to use -r, which basically means read from this file. And the file is located in this folder, and the name of the file is capture.pcap. Once again, verbose mode. So if you recall, we were using -i docker 0 previously, but in this one, we want to read from this file, not from an interface. And then the protocol type is ICMP, as we already know, and source host is 172.17.0.2. There you go. Also notice that we didn't need to trigger this rule, right? Because this is already there in the file. So tcpdump was able to just parse the file and give us the final results. And as you can see, it has just identified ICMP echo reply messages, because these are the ping message replies coming from Nginx container, source host Nginx container, and protocol type ICMP used for pings. Okay, so that's perfect. The next one is to filter on protocol and destination port, as well as using the source host and destination host. So what we want to do? So we want to get all of the DNS messages that were sent from Kali Linux to the Nginx container. So DNS, we already know it's UDP. And we also know that these packets are basically going to destination port 53, because whenever you run a DNS query, it always goes to port 53, and the response also comes back from port 53. And in addition to that, we also know that these messages are going from Kali and to Nginx container. So now we will try to be more precise, especially for the challenge, because you'll need to be very precise. You'll need to give all of the filters that you can. So let's solve this one. So sudo tcpdump as always, and then -r because we want to read from this file, capture.pcap, and then -v for verbose mode, UDP because we are talking about DNS resolution, DNS packets, and then destination port is 53 because at the destination, when you're contacting a DNS server, you always specify port 53 as the destination port. And now you want to be more precise. So you can use more and chain a lot of different filters. So usually when you're doing a forensic investigation, you want to be very specific. Yes, sometimes you need to keep the rule or filter broad because you want to see, for example, what are all the different DNS resolutions done. But sometimes you need to be very specific, coming from this source, going to this destination on this port using this protocol. Okay. And especially you'll need that to solve the challenge in the lab as well. Okay, so we know that it is coming from Kali Linux, so for which we have the IP address 17.0.1, and we know that it's going to destination Nginx container 0.2. There you go. So basically we found out that there are two different messages. So as you can see, this is coming from Kali Linux and going to Nginx container. And port 53 refers to domain name resolution. So one was Kali Linux is asking Nginx container, can you please tell me the IP address for example.com? And the second one is that Kali Linux is once again asking Nginx container, can you please resolve google.com and give me its IP address? So Nginx container is sort of acting like a DNS server. Whether or not it actually resolves or not, we're going to see that later on. Okay, so far so good. So now going on to the challenge. Let me just zoom in a little bit. So the first thing that you need to understand for this challenge is that you need to run these against the capture.pcap file, which is already included in the lab, which we have been using here as well. So you're not required to use the Docker 0 interface, okay? You just need to parse this file. So what's the first challenge? The first challenge is you need to run a command which shows only DNS responses from Nginx container to Kali Linux. And as a hint, I've also mentioned that DNS responses also originate from port 53. So the request also goes to port 53 and the response also comes back from port 53. So what do we want? We want all the DNS responses sent from the Nginx container to Kali Linux. So Kali Linux asked to resolve something and then Nginx container answered those DNS queries, and that's what you want to find out. Second is that your team has realized that there has been a data exfiltration attempt from the Nginx container to a remote malicious command and control station. And your manager has shared the packet captures and they want you to help them identify the name of the remote malicious server and the IP. Now, you know that a DNS query must have been sent. So we are imagining that the Nginx container became compromised and then it tried to contact a remote command and control station. But as you know, before you can actually send packets, you need the remote command and control station's IP address. So for that, the Nginx container contacted Google's DNS servers to resolve that name. So now it's your job to do a forensic investigation and find out, number one, what is the DNS query that originated from Nginx and it went to destination port 53? We don't know the IP address of Google's DNS server, so that's about it. So this will be sort of like a generic filter. However, once you have found out the name, the next step is that you also want to write a command which is going to filter and give you the traffic, the DNS response, which is coming from Google's DNS server. And you don't know Google's DNS IP, so don't worry about that. But it's coming from source port 53 and going to Nginx container. And then you need to find out the IP address of the remote malicious host. I'm going to quickly revisit the architecture and explain exactly what is required. Okay, now for this challenge, so we have the Google's DNS server somewhere here. And then we're talking about this Nginx container basically trying to resolve the DNS of that remote malicious server by contacting this Google DNS server and then receiving the reply. So when going, it is the DNS query and the reply would be the DNS response. So you're going to write filters which parse the capture.pcap file and first identify the traffic going from Nginx container to Google DNS server for DNS resolution and then the response from Google's DNS server to Nginx container. So please go ahead, try to solve this lab and we're going to discuss the solution in the next lecture.